Okay, so behind me is a giant mural diagram on 5 sheets of plywood that depicts a part of a much larger diagram that perfectly divides the circle into 360 degrees. So I've written a book about how to do that called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dawsonal Geometry. So it has to be drawn on a base 12 Cartesian plane. So what I'm going to show you right here is the heart of the diagram. It's just this little scribble on some graph paper where we have 3 lines that are each the length of 0.5 root 2. You know, this one here, there, and this one there. And you can see it sort of attached to 3 triangles. This one's pretty obvious. This one's 0.1 and then 0.7 along there. And then it's the same here, but you also have this 3, 4, 5 triangle, but in units of square root of 2 or 0.2, or 0.1, 0.2, 0.3 root 2. Okay, so that's if you just play around with that and ask yourself, what's the difference? What base is this graph paper? That's the question to answer. What's the difference if we approach that little bit of geometry in base 10 or base 12? That's the key, and that's the sort of mind switch to approach that. Like, you sort of know what a 1x1 square looks like on graph paper in base 10. What does it look like in base 12? And what's the relationship of that little tiny diagram? If you continue it, you can create a sort of a polygon out of sections of 0.5 root 2. So all the sides are the same. There's 12 sides, but it's not a regular polygon at this point. Those distances, if you draw 2 circles, that's the heart of this diagram for 360 degrees. And that 360 degree diagram is the heart of something even much more, the geometry of the circle, where you can literally plot millions, billions, trillions, gazillions of points, all perfectly symmetrical. The distance between them on either side is equal. They're all equidistant from the center. What you end up creating are polygons with millions and billions and trillions of sides, and then that polygon is like the structure upon which you can plot your points. All the angles are the points that define that polygon. So that's how you do it. And so the polygon isn't the circle, but it defines all those points. You can sort of define them all, take the polygon away. You got literally as many points as you think you need to define the perfect circle. Okay, so that's what this geometry is all about. That's what my book's all about. It's a new discovery. And that's it. Hope you find that interesting. If you find it interesting, follow me, buy the book, and let's spread the word.